watch teams working, and it's almost like watching somebody try to cut something with like a dull chisel. Or it's like watching them like try to use a dull handsaw when the table saw has already been invented. And so I look and I often see people managing to do incredible things, but they're doing it in spite of the tools. And so one of the things that we've really tried to do at Autodesk is bring people better tools to get the job done. And I think there's a reason why, why the tools are actually failing the engineers. So when you look at the new world of crowdsourcing, constant decisions about, do I make it here, do I make it there? When you look at connected devices everywhere, what's going on with digital fabrication, you start saying to yourself, the tools that were built before were not really built for this environment. The engineering tools that many people use were really built for large companies. They were built for large companies in doing aerospace and defense and military work. They were not at all built for small teams. And if you just look at the trends out there, if you look at manufacturers who make products, when they went through a whole era in which the only thing that people were concerned about was quality. You know, it was Six Sigma everything. Then there's a whole nother wave of time in which the preoccupation is on cost. How can we offshore? How can we get things as cheap as possible? But today, if you look, there's really two things that companies are primarily interested with, and this community does it better than almost any of the large companies, which is all about agility and it's all about innovation. How do I get a product to market more quickly, and what differentiates my product from everybody else's? So I look out there and I see there's these incredible tools with hardware and software tools, the Arduinos that Massimo showed. You look at what's going on with digital fabrication. We'll talk a little bit more about additive and subtractive manufacturing. This is something that I love, what's going on with new materials. This is done by a bunch of people from the University of Stuttgart. It's a kiosk. It's built out of carbon fiber. The really cool part of it, it was laid up by 2 robots. So it's a wet layup of carbon fiber of an architectural structure done by robots. For those who like watching this kind of CNC porn, there's a great video of this online. I alternate between watching these robot do things and the CNC machines, and my kids are always coming in and saying, "Are you watching that stuff again?" The really bad thing about CNC porn, it either has this really cheap music that they somebody stole off the internet, or it's just the sound of the machine tool. It's just going, and so they're like, "Okay, you've been doing this for an hour, Dad. Could you stop?" But I think the materials are also incredibly interesting. Okay, let me just move on a little bit to software. Last year I was here, or wherever we were last year, and I talked about this product that we introduced that was called Fusion 360, and I'll tell you about it in a second. But one of the things I've already gotten asked about a lot this morning is, what are companies like us doing to make sure people have tools? What are we doing in the schools and stuff? And one of the great things that I think we did this year is we made every piece of software that we have available to schools, faculty, and students. So anybody can get a license to any of our professional software by just going up, I think it's students.autodesk.com. People get a 3-year license and it's available. People always think there's a catch or there's something more to it. There really isn't. You just go there, you download the software, and it's available. So I think for those, when we go back to communities where people are asking, students.autodesk.com is a way to get it. In addition, probably people know about some of the other things we've done with products like Tinkercad, the 123D series design, 123D circuits. So there's lots of interesting stuff there. But in particular, last year I came here and I talked about this new product called Fusion 360, and it was a cloud-based CAD tool. It was a design tool. And I introduced it and I thought, really there were 2 things about it that I thought were unique. One is from the ground up, it was really designed for small teams of people working together doing interesting, innovative stuff. And it concentrates on 3 things. It's form, function, and fabrication. So all 3 things put together in something that was made for small teams to work on. And it really fits this kind of community. Second thing we did is we actually did something different about pricing it. So the first thing is, for commercial users, it was $25 a month. And for anyone who was in a startup, do-it-yourselfer, hobbyist, it was free. So and that's true, and it'll be true forever. So everybody can get access to it. So let me give you a little bit of an update. Now that we have tens of thousands of people using Fusion 360, there's a little bit of a list of some of the stuff it does. So I love this video. One of the things is, people are no longer just designing and starting from scratch. So this is scan data of somebody's leg. This is a prosthetic project. So that's data that comes from out there. In this world of sensors and acquiring data from lots of places, this is going to become more common. In 1 second you'll see. So we just took scan data that's can be kind of noisy and just fit in a perfect analytical surface to it. I think it's a more interesting way and a more common way that people are going to get there. Many of the things we build are already related to things that exist in the world. This idea of starting every project with a blank sheet of paper is not really the way design is getting done. Second thing I wanted to show was, one of the things that we think is important is not just the form of these things, but the function. And so we integrated simulation in a way that was reasonable for engineers. So this just shows, here people can test things like drop tests. They can test things like, is it strong enough? They can test whether or not I can cool this. Will it get too hot? So those are the kinds of questions we think designers need to be answering, and they need to be answering it in real time. And the reason why I think it's important, one is the sooner you get an answer, the better you can do your design. But the other reason to have this instantaneous feedback is I think as a designer, the more you work with and get instantaneous feedback, the better you build intuition over time. You get feedback and you learn a little, you get a little bit more, and as you go, you develop an instinct for what are better designs and what are worse designs. Here's just one of the things that we've been doing. We've been moving our visualization to the cloud. So this is a cloud-based rendering of this prosthetic device. This was for a woman who was in the military, lost her leg. She was an avid sports photographer, and this was 2 small companies that worked together to design, engineer, and build this replacement. Here's a drawing. Drawings are still out there. When you send them to places to get manufactured and things like that, they're still an important part of the workflow. One of the fabrication techniques we think is incredibly important, we see it in the devices all the time, is 3D printing. I'm going to talk a bunch more about 3D printing this morning. That's part of the announcement. But we think 3D printing has gone a long way, but there's more to go. And so we integrated 3D printing. And the other part is we integrated CAM software. So we took this, and so we integrated CAM software so that people could machine right from their models. Let me show you a little bit. One last thing. This is all about being up to date on projects. One of the things that always drives me nuts is I know more about my neighbor's kids today than I know about the projects I'm working on. That seems wrong in this day and age. We should be up to date on all the people. And so we should have the same kind of tools that we have for keeping aware of our social context. We should have the same things for the projects that we're working on. Here's making the designs available on mobile devices. So this whole thing's connected, it's working, there are people out there using it. I encourage people who are looking at doing many of the projects that I talk to folks here, take a look at Fusion 360 for doing that. Here's one example. There's a small one outside, robotics. There's a small group, a bunch of students out of ASU, built a robot, it's like a Roomba up on its side. The cool thing is when you turn it up on the side, you can do things like climb stairs. It's a fun little project they did. This is a project I really love. This is Makatuba. It's a young man, Joshua from Uganda, who had this idea of being able to make a breathalyzer, essentially, for a test for tuberculosis. So this device combined with your cell phone, and it's a test for tuberculosis. And I love people doing these really interesting things. They're not mainstream, but they're incredibly valuable to people. I'm a user too. This is my son, Will. Will and I have been, that's a model of our, I was going to say our go-kart, I should say it's his go-kart. I also have Dale to thank for Maker Faire. As Massimo said, these projects are never really finished, but it's great having a deadline. So we're taking the go-kart to Maker Faire on Saturday. This was a fusion model of it. fusion renderings of it in some exotic locale that doesn't really exist. And there's another exotic one that looks incredibly real and sexy. And there's the reality. there's really one of the ways you always know when they're in those renderings, if you ever wonder if it's real or not, look for the wires. You know, in real life, there's wires and tape everywhere. And all the pretty renderings, there's never a wire in anything. None of that stuff would ever work. Okay, second topic I wanted to talk to, I want to move on to this idea of what's going on with CAD software, design software. CAD software. I've had this belief for a long time that, CAD stood for computer-aided design. The computer actually didn't do much aiding. It's really like computer-documented design. We use the computer to document our designs. It doesn't help much. So we started spending a lot of time on how computers could help. And I have this fundamental belief that what will happen over time is that computing is going to almost become free. Then you will have an infinite amount of computing, and then you ask yourself the question, what would you do if you had an infinite amount of computing? How would you design and engineer things differently if you had all the computing power in the world? So this is some thought experiments we've been working on for the last few years. Here's the idea of a bicycle. Here's a different kind of structure. Structure comes about by running thousands of iterations of analysis software and letting the computer generate some form. So what you're really trying to do is you're trying to drive the results. You say, here's what I need. It needs to support this much. It can weigh no more than this. It needs to be contained in this envelope. And this is a design that wasn't done by a human. It was done by a computer. And you can see the crazy structure. I, for one, would not want to model it in Fusion or anything else. And you can see what it looks like. This is a heat exchanger designed by the same process. This is an airplane. This is some work we did with Airbus that contemplated what an airplane in the future looks like. You can see the parts of the plane that really need to be there. The rest is just the legacy that comes from being a submarine that they put wings on and said it could fly. Really, that's where the strength needs to be. The other places could be structurally different, and you can see it in this example. So this was an idea we started to get to. And part of the idea was that many of these things that you look at these, whether you think of that heat exchanger or a bicycle, the only way to make them would probably be with some additive technique, with some kind of 3D printing. And then one of the really interesting things that I've seen happen this year is this combination of 3D printing along with traditional milling, so additive and subtractive combined. And I think this is going to be an important thing going forward. There's a lot of benefit that comes out of combining the two. You kind of get the material savings, plus you get the shape complexity of 3D printing, but you get the precision of traditional milling. And so you think of this, and this was a lot of motivation. So we started saying, this 3D printing is going to get really interesting, and if you could tie it back to the design software, you could all of a sudden design things and make things that you never imagined before. This is the motivation for what led us. Imagine flying in a plane like that. Looks a little Star Wars, a little Enterprise. So let me just talk about 3D printing and move on to the part of a couple of announcements. So when it gets to 3D printing, I've been fascinated by the promise of 3D printing and a little bit frustrated by the reality of it. There are days where it's awesome, I model something up, I run it over the printer, I get it, it's great. Go-karts full of 3D printed parts, I use it for jigs and fixtures all the time, and then there's other days I go over and I get cotton candy, and I wasn't looking for cotton candy out of my 3D printer. The other thing, having grown up in the world of software, one of the things about software is you could basically stand still, and over time, stuff got faster. And that's because the microprocessors got faster, and they got faster in a predictable way. All about Moore's Law and things, you could do that. One of the things that's different about 3D printing, I would say, is that you don't have that natural tailwind that comes from microprocessors getting faster. This is going to be a different curve in terms of its improvement. Number one, you're fighting, things being raised to the third power. If something, if you print a 1-inch cube and it takes an hour, that's okay. If you want it twice as big, it's going to take 4 hours. And if you want it twice as big again, it's going to take 64 hours. So you've gone for something 4 times as big, and now it takes 3 days. You're fighting that all the time. So as opposed to Moore's Law, which is on your side, just the power of 3 you're fighting. Second thing is, by not having microprocessors, you also have this problem in that when I think the advancements in 3D printing are going to be much lumpier. You're not going to be able just to sit back and know next year computers will be twice as fast. There'll be lots of great experimentation. There will be lots of innovation. People will invent new things, but it's going to be lumpy. So these are some of the problems that are out there with 3D printing. So one of the things that we wanted to announce today is we're making a new platform for 3D printing. And we're making it open, it's free. We will license it freely to any 3D printer manufacturers or anybody else. And it's software for things like toolpaths and slicing and support material, and everybody can have it. And just want to kind of raise the level of what's going on. And so have everybody have access to the basics so we can get on to the next hard parts and move on and give people more control. And if you go back to what motivates us, it was when you see the designs like I showed you before, like the airplane or the heat exchanger, you really need granular control of your machinery in order to print things like that. And we'd like to be able to have that level of control. So the second part of the announcement is we're making an open and 3D printer. So there's the 3D printer. It's a photopolymer printer. We're going to make it open. We're going to take the designs. We're going to share it with the community. Everybody can have access to it. What we'd love to see is more exploration, more experimentation. What we're really interested in seeing is the combination of hardware, software, and material science. And we'd like to work together with everybody on this. So both the platform, the software platform Spark, plus our 3D printer will be available later this year. And we're looking for, oh, there it is. There's the plans that, we will publish if everybody can get them. And you can get any information you want. The software platform called Spark or the 3D printer. So we're looking forward to working with the community. Hopefully we can take where we've gotten so far and move it a lot further. So thanks very much. And
So I had this document in that we've got Intel talking about hardware, we've got Autodesk talking about software, and you throw Gerb in here, you're introducing hardware.
we screwed it up totally.
Yeah.
That's why I didn't know what I was talking about.
What's the name of the 3D printer?
We need a name. I think we need to crowdsource it.
All right.
We need to crowdsource the name.
Okay.
So right now, the software platform is called Spark.
Right.
We got that, and
What?
Spitball.
Look up this.
Look at
Plug.
So any questions, comments? Jerry?
I love your open source. The availability of the hardware and the software is wonderful. The biggest barrier that I have to using any of the CAD/CAM equipment is training.
Yeah.
It is really hard to learn this stuff. The learning cliff on AutoCAD is immense, and the schools locally charge thousands of
I
dollars
did not
to
start
run.
with AutoCAD.
Or SolidWorks. I mean, it's like
I
$5,000
wouldn't
machine.
start with SolidWorks.
What would you start with?
Okay, so
Like this is
let me give you a couple of things. So, I always do this talk in Maker Fair. I've done it the last couple of years called CAD for Kids, but it's generally starts with the question of, I want to get started, what tools do I use? I think there's a range of tools. One thing, the things, the real base, and it doesn't get you all the way there. The two things I say. If you just want to see how do I model something in 3D and how do I get an idea and a feel for it. Not quite your question, but that's where I started. Then I looked at the 1, 2, 3D stuff. Most people nowadays, I would point them to the Fusion stuff. And then for the professional stuff, you know, there's the Inventor and SolidWorks and Pro E and stuff like that. The way I find, I think many of us want to learn is just in time. And the way to look, the best information I see out there is on YouTube. Almost by far, when I go out and ask our customers and we survey, it's almost always go to YouTube, find the video about the thing that you're actually doing. And you know, that's what made the same point about Arduino. You know, it's this concentrate off between simplicity and power. How powerful is the tool? What can I do with it? But that's what we really try to do, a little bit similar to the Arduino with Fusion was this idea. Let's make it simple and give you most of what you need, but maybe not everything. So
you actually see in the audience, I'm asking you to raise your hand whether you consider yourself a novice or haven't even started, whether intermediate level or advanced level in 3D modeling, you know, CAD tools. So how many people would consider themselves sort of a novice or you've never really done anything significant? That's a pretty good number. How about intermediate level? You've done some things. Okay. How about advanced? Okay.
Yeah, it is. Yeah. And particularly when you get to the electronics projects, you see less advanced, you know, 3D models.
Right. So I think Jerry's question is a good one, as like we could figure out. I mean, some of the tools are getting really much easier, and the idea of sharing objects so that you're building.
Yeah, you know, there are places like GrabCAD where there are models. I don't think you should start from scratch. I showed you that one example of in the orthopedic of taking a scan. I think a lot of times we can capture stuff that exists in the world and start from there. So I think there are better starting points, but if you're just looking for info, I think YouTube is probably the best place to look for info.
Yeah. Question back there.
How is the new printer going to be different from the regular, you know, additive printers like you see all the time, you know, the filament printers?
So these photopolymer printers actually, they do a number of things very differently. There are a couple of photopolymer printers out there that are Kickstarter projects. We're not the only one with a photopolymer printer, you know, by any stretch of the imagination. Generally what you can find out of them is a different chemistry. You end up with different materials. You can get much finer detail than you get out of the filament printers. You guys did a good report on it. Making a really nice report, you know, kind of explaining the differences between the 3D printers and why you might buy one versus the other. By the way, our printer is not really intended, I think, for the home. This is, you know, to be in a business, it's people who are prototyping and using it. That's what that printer is more appropriate for. I wouldn't mind more than one photopolymers, you know, I'm sure running around the house.
That's our chemistry problem.
Yeah, you know, we've thought about, we hadn't announced the price point, but you know, these printers are in the $5,000 price point range, different than, you know, maybe the filament printers, which are down in a couple thousand price point range. You know, the thing for us is really, what we see, and you know, it's unusual not to see this, is this integration of hardware, software, and chemistry. And you know, nowadays you're seeing increasingly that hardware and software are being sold together. You know, there's lots of jokes about which one's selling which. But you know, I use the example of the Nest up there, but there's many examples where the best user experience for 3D printing will come from a good combination of hardware, software, and chemistry.
How long a development process was behind this 3D printer, and when did you have to say yes to that?
Today's Wednesday? Monday afternoon? Again, these deadlines are good things there. I thank you again. You know, this project is probably, I mean, we probably in a year. Okay. It's probably been a year in the making, and, you know, they're completely done, you know, there's more things to do. I mean, anyone who's ever built anything, it would be odd for me to find anyone who's ever built anything when they're done and just say, you know what, that one's perfect. You know, every project I've